Yeah, let's see if that helps. Yeah, it sort of helps. We will do some kind of combination of things up here and things on the handout, and it'll all work. We'll figure it out. Okay. So hi, thanks for coming. So there's this thing that's been going on lately in philosophy and in epistemology in particular, where as if it wasn't bad enough to have a Bayesian epistemology that assigns real numbers to propositions, it has now become very trendy to assign ranges of real numbers to propositions. And this view goes under a number of names. I'm going to call it the ranged credence view for reasons I'll explain shortly. And basically what I'm going to do today is I'm going to talk about that view. I'm going to talk about it as a phenomenon in epistemology and philosophy in general. This is part of a broader thing. I'm writing a book called Fundamentals of Bayesian Epistemology. The title pretty much explains what it's about. And there's a chapter where I spend a lot of time talking about ranged credences. So that's basically what I'm going to present today. If you're going to write a book about Bayesian epistemology, you have to say what you think Bayesian epistemology is. So at the beginning of the book, I give a very loose definition that's meant to include a lot of different views. And this is what I say. I say Bayesian epistemology endorses two things. First of all, agents have attitudes that can usefully be represented with distributions of real numbers over propositions. That is a purely descriptive claim, right? It's a claim about agents having things in their heads that can be usefully represented in a particular way. And then there's a normative claim, which is that there are rational requirements on these attitudes. And once you've represented the attitudes with distributions of real numbers over propositions, you can represent these rational requirements using mathematical constraints on those distributions. And the mathematical constraints, if you're a Bayesian, are in some way tied to the probability axioms, usually some version of Kolmogorov's axioms, right? So we have a descriptive claim and we have a normative claim, and that allows for a lot of variation. Among other things, it allows for this ranged credence flavor of Bayesianism, the basic idea of which is that you're going to represent an agent's attitudes with a set of probability distributions rather than a single distribution. Okay, so the moment you start doing that, you run into a complaint, right? And this is actually a complaint that Bayesians hear all the time, whatever kind of Bayesian you are. People don't have numbers in their heads. It's incredibly unrealistic to think that actual agents have real number values down to arbitrarily many decimal points assigned to each proposition they can entertain. And then if you've got that problem with a view that assigns one real number to each proposition, you're going to have that view at least doubly for a view that assigns a range of real numbers to each proposition, because, hey, now you've got at least two numbers for each proposition, and that seems even less realistic. So what do you say about all that? What I say is this isn't really the right question, or at least it's not the question that I'm interested in. Okay, I'm not interested in even what it would mean to say that people have numbers in their heads. What I'm interested in is you've got these agents and they have attitudes, and the attitudes are very complicated and subtle. And they can stand in all sorts of relations, and in particular they can stand in various structural relations. And then for a variety of reasons we want to have a formal representation of those structural relations. And so the question I'm interested in is what kinds of formalism can be useful to model those structural relations among whatever the heck is going on in people's heads. Now, a few notes about this question. First of all, it's not clear at all that there should be a unique answer to this question. In fact, there's probably not. If you're looking at different structural features of people's attitudes, you're probably going to want to model them with different types of formalism. Second of all, there are plenty of other questions one could ask, right? I mean, I'm doing epistemology, so I'm asking a question about agents' attitudes. Bayesian formalisms can be used to model all sorts of things that aren't just agents' attitudes. Right? So there are all sorts of things you can do with the formalisms I'm going to be talking about today. I think different formalisms can be useful for different things, even when you're answering one and the same question. I'm going to talk about the epistemological, and in particular the philosophical conversation about how some of these formalisms have been used to represent agents' attitudes. Yeah? Here.
Will you explain what, I mean, is there something more specific about what an attitude is? Or
yeah, we're going to approach that kind of sideways, I think. So I'll start giving you some examples. on the next slide. I mean, the types of attitudes we're talking about here are so-called doxastic attitudes. For a philosopher, that's meant to mean something. It's meant to mean something like belief-like attitudes, right? Some people find that designation helpful. For some people, it just raises more questions. But that's kind of the environment we're working in here. And like I said, in a moment, we'll get some concrete examples. I should also say, I'm just going to kind of run this from the very basics on up. And I'll go through the basics pretty quickly, but just to make sure we're all kind of on the same page. If you have any questions about the very basic parts, please stop me and we'll pause there. Here's what I'm going to do. Overview of the whole thing. I'm going to talk about why do we want this range credence formalism to begin with, given the question I'm interested in asking. Then I'm going to talk about 3 features of evidence. 3 different features evidence can have and how they interact with these range credences. And then I'm going to talk about dilation, which is supposed to be a problem for the range credence formalism. And I'm basically going to say why I don't think dilation is a problem, even in a more sort of refined version that's popped up in the last 10 years or so. OK, so here's an example, right? Here's an example of the kind of attitude I'm talking about. So I was at a conference in Tucson in January, and I had to leave the conference early because I wanted to get home for my oldest daughter's 10th birthday. But of course, I tried to stay at the conference as long as I could, so I pretty much booked the last reasonable flight out of Tucson on a Saturday that would get me back Saturday night, because my daughter's birthday was on Sunday, and you all can see where this is going, right? We all got loaded onto the plane. They went to close the door to the plane, and they found they couldn't close the door. And so they called the mechanic, and the mechanic couldn't close the door. And all this was going on, and we're all sitting on this plane. And so I get on the phone with customer service, and I said, hey, is there any other way you can get me back to Madison tonight? And they said, well, the only option is we could fly you from Tucson to Los Angeles to Las Vegas to Chicago, and then I could have taken a bus from Chicago back to Madison, and that would have gotten me home the next day, I think at like 10 or 11 a.m. So this was a suboptimal outcome, okay? And so I wanted to know, hey, are we, I'm supposed to be flying to Houston and making a connection. Am I going to make my connection? Flag down the flight attendant. I said, hey, am I going to make my connection? The flight attendant obviously was uncertain of what the outcome was going to be. This is something the flight attendant could have said. Real people don't talk this way, but I think this would have been an accurate representation of her doxastic state at the time. She could have said, look, I don't believe that you're going to make your connection, but I also don't believe that you won't, right? This would have been a full belief report, right? And the first formalism you always go for in this kind of vicinity is the formalism of full beliefs. You define a propositional language, and then you say, OK, here's the list of the propositions that the agent believes. Maybe if you get fancy, you also have a list of propositions the agent suspends judgment on. OK. Problem being, this doesn't give me a ton of information, right? It's not sufficiently fine-grained for my decision-making purposes. And the funny thing is, when I actually asked the flight attendant the question, what she said was, I'm more confident than not that you'll make your connection. Which for someone in my line of work was an absolute dream of a statement to make, right? You don't usually catch real people saying things like this, right? But notice this gives me more information than this report. And this is the kind of thing you can also formalize, right? You can get a comparative ordering going on, so you can get a language of propositions, and then you can introduce an ordering, either total or partial, over that language of propositions. So what she just said is, I'm more confident of the proposition you'll make your connection than the proposition you won't make your connection. All right? And this is the descriptive bit. You have this ordering that represents the agent's attitudes. And then there's a normative bit, so a whole bunch of people have offered axiomatizations for comparative confidence orderings, starting with Dave Finetti and running through Scott and all sorts of folks since then. Okay? Are you beginning to get an idea of the sort of attitudes I'm talking about?
Oh, yeah. No,
OK, good. Yep. Absolutely. OK. So there's a formalism, comparative confidence orderings. Big shortcoming to this formalism, obviously, is you can't get gap sizes, right? I want more information from the flight attendant than this. I want to know, how much more confident are you of this one than this one? Because I got to make this decision about whether to get off a plane or not, right? So if I could have more information about how these two things compare, then I'd be in a better situation. All right. This takes us to the sort of traditional Bayesian formalism where you introduce point-valued credences over your propositional language, right? Okay, so you've got this real number distribution over your language of propositions, and then your rational constraints are the probability axioms. Fine. At that point, you can now measure gap sizes, and you can do it in two ways that are particularly salient. First of all, you can look at differences between credence values. So you can look at your credence in A minus your credence in B, and then your credence in C minus your credence in D for some propositions A, B, C, and D. And you can ask which of those gaps is bigger. The reason I bring that up is that's the kind of comparison you need to be able to make to do decision theory. To make my decision about whether to stay on or get off the plane, gap size information of this sort is what I'm interested in. All right, obviously this is the kind of thing that's preserved under affine transformations and things like that. That's why it's relevant for decision theory. The other thing you can do besides looking at gaps is you can look at ratios. Ratios are important if you want to define conditional probabilities using your standard ratio formula. And so you use ratios to do things like look at correlations, look at independence. These are the things you want to look at if you're going to update by traditional conditionalization. So these sorts of things, ratios between credences, are the basis for confirmation theory. And basically what I say in my book is, historically, the two most important applications of Bayesian epistemology have been to decision theory and confirmation theory. So once you have these two abilities to measure gap sizes, you can do those two things, and then you're off and running in a whole bunch of ways. Now, of course, if you're familiar with the history of Bayesian epistemology, this formalism has all sorts of problems, and we could go through a lot of them. Got a full 4 chapters in my book about them, but the one I want to focus on right now has to do with commensurability. The moment you have a propositional language and you have assigned a real number to every proposition, you now have the ability to compare every proposition. And in some cases, that's good, because what that means is this can give you all the information you would get out of a comparative ordering. I'm more confident in A than B, just in case my credence in A is higher than my credence in B. But sometimes we don't want to be able to make those comparisons, or perhaps more accurately, sometimes we can't make those comparisons. So I might give you 2 propositions and say, which one are you more confident in? And you might say, I have no idea. And there's 2 reasons you might say that. One reason you might say it is maybe you've never considered those propositions, or you've considered them individually, but you don't know how they compare. The other reason is maybe you've considered them a great deal, and you honestly don't know what to say about how to compare them. Maybe your evidence doesn't support a rational comparison between those 2 particular propositions. The moment you have real numbers assigned over your entire propositional language, you're stuck because any 2 propositions in the language become immediately comparable because they both have real number values. Now you can finesse that a little bit. You can move to doing partial distributions. So you only assign real numbers to some of the propositions in the language. That actually doesn't get you all that far. And here's a really good reason why. So suppose you have an agent who's like this. Okay, an agent who meets all 4 of these conditions. So the 2 propositions we're going to be interested in are the proposition that it will rain tomorrow and the proposition that there's alien life in the universe. Suppose our agent is more confident in rain than not, more confident that there's alien life than not, treats these 2 matters as independent, as I think would be reasonable, but is unwilling to compare the prospects for rain tomorrow and the prospects for alien life. This seems like a perfectly reasonable way for an agent to be, and you can cook up an evidential situation in which arguably this seems like the rational response. Yet there is no way to represent this agent in either of the formalisms I've shown you so far. Just run through quickly why not. In the comparative confidence ordering formalism, you don't have ratios, so you can't make independence judgments. There are ways of patching up the comparative confidence thing that can deal with this. We can talk about those if you want. But basically, in the basic formalism, whether it's a partial or a total ordering, you're not going to be able to get number 3 here. What about the Bayesian one? Well, you can get the independence thing, right? Because you just get your ratios lined up, and that's fine. The trouble is, in order to get a comparison between R and not R, you need to assign real numbers to both R and not R. And then in order to get a comparison between A and not A, you need to assign real numbers to those. And the moment you've done that, I can now compare A and R just by looking at the values. So if you satisfy these two, you can't satisfy this one, and vice versa.
So
Yes?
The comparative case was when you just say, I'm more confident.
Yeah.
Right.
Yeah.
So, I mean, in that case, I mean, you can't get 3, but, I mean, there's not even there's not even a concept of independence, is there? Or, I mean, do you have,
Well,
what does it even mean?
the way I think about this is you've got an agent, and the agent has a whole bunch of attitudes. And I think agents are capable of understanding and talking about concepts like independence, even if they don't use that terminology. So I imagine we've got an agent, and it's a feature of the way that agent looks at the world, that that agent treats these two matters as independent. Okay, and that could get operationalized in a whole bunch of ways if you want, right? And then the problem is we're trying to find a formalism that captures all these aspects of how the agent sees the world. And the problem is the comparative confidence formalism can't capture that third aspect. So it's, yeah, sorry.
I mean, let me second Harry's reticence about accepting that. We have a theory of probability, and we know what independent means inside that theory. But to take it outside of that theory and say it means something doesn't seem very convincing to some people.
Okay, true. A really simple way to get at it is to start asking the agent about conditional things, or to see how the agent updates, right? So for instance, suppose you said to this agent, hey, I just found out that it's going to rain tomorrow. Does that change anything about your attitudes towards alien life, right? Presumably the agent I'm thinking of, no change is going to happen in how they feel about alien life. Moreover, instead of actually giving the agent that information, you could say to the agent, hey, if I told you what the weather is going to be tomorrow, would that make any difference to how you feel about alien life? And the agent would say, presumably no, right? And these are the sorts of things that, to me, make it plausible that the agent can be described as satisfying this third condition. And notice I haven't talked about probability there at all. So I haven't put the agent inside. I haven't forced the agent into a particular formal representation. I've just started asking the agent questions about how he or she views these matters as related to each other. And I think it's pretty plausible that you could have an agent who just says, look, I don't see these two things as connected at all. Right? Yeah, Laura.
So it seems to me like the comparative confidence thing might be able to capture something like independence, or I'm not clear on how it wouldn't. Can it include something like is not greater than, is not less than? I mean,
sure.
Yeah.
Right. You normally, when you set up these formalisms, you have greater than or equal to, and you have greater than.
Right.
It just turns out that you can show that for a heck of a lot of comparative confidence orderings over a somewhat non-trivial propositional language, listing a total ordering over the language underspecifies the ratios, and in fact underspecifies the correlations and things like that. So I can give you an ordering over a language, right? A total ordering over the language, and then I can basically write down two probability distributions that are consistent with that ordering, and one of them has A and R correlated in one direction, one of them has A and R correlated in the opposite direction, a third one has A and R independent, et cetera, et cetera.
Right.
Yeah. So the problem is the orderings underdetermine the independence facts. Yeah. And that's actually, there are ways you can play with this, and that actually turns out to be a pretty recalcitrant fact about the way these formalisms go. So one thing that has been attempted is to actually build a formalism for comparative confidence that starts with comparative conditional confidence as primitive. And you can get farther towards this sort of thing if you do that. The basic problem with that is ultimately what you're probably going to want is you're going to want the comparative ones to be related, the conditional ones to be related to the unconditional ones in some interesting ways, and the formalisms for primitive conditional comparative confidence don't tend to pick up on those relations. So there are ways to sort of patch up the most basic comparative confidence formalism to get you this kind of thing, but then it turns out this thing doesn't interact with other stuff as strongly as you would want. Terence Fine has a great discussion of this. Fine hits the point where he wants a formalism, and then he wants a whole nother formalism to represent independence, and then he tries to get the two things to work together. Yeah. Yeah, Jude.
I was going to suggest that last thing.
Right, yes. So that's what he does, right? He eventually adds a whole nother formalism on top of the thing. And then there's this, just to get independence. And even then, it's not clear if that's going to pick up all the subtle correlation facts that you want, right? And it's also not clear at that point why you shouldn't just go to the ranged credence formalism. It's not clear at that point if you've saved yourself any trouble, is the other thing, right? Yeah. Yeah.
So what would prevent me from doing the following thing for the second formalism? You said, let me recap
Right.
the point. The point was, insofar as you can do 1 and 2, then you can do 4. You
You can't do 4,
because
right?
then you get an
Yeah,
ordering,
right.
So what is preventing the formalism from me just saying something like, I'm going to order the propositions, only a proposition and its negation? Those are the only things that I'm going to compare.
Yeah, then I could just come up with an example where the person is willing to compare A to B and C to D. A and B are not negations of each other, C and D are not negations,
but
right?
then I come up with another alcohol.
Yeah, so eventually what you're going to wind up having
one of the
is...
question is, why,
right.
why do you, it seems like,
Right.
it's too much to conclude from the fact that you can order any subset of propositions. They can only be ordered as part of a total ordering on everything.
Right, right.
Or the formalism, because
Yeah,
you're talking about
sure,
formalism. Right?
sure. Yes. And this, by the way, is exactly the kind of conversation I think we should be having. Really interestingly, this is not the conversation most people are having that motivates them to use ranged credences. I'm going to talk about that conversation in a minute, but notice, I think this conversation is really, really important. Because notice, first of all, this is mostly a descriptive matter, right? We've got these agents and they've got things going on in their heads, and we want to ask ourselves, what kind of formalism do we need to capture some complicated things that could be going on in their heads? And you're right. So one thing we could do is we could have a distribution of real values over the entire propositional language, and then we could have an added thing on the side that tells us which pairs of propositions that agent is willing to compare and which ones they aren't, right? So that would do it. And then you wouldn't need anything ad hoc. You would just contain all your information in there, right?
What is the motivation for wanting a formalism? That you said here's a person that thinks these things. Why do you want a formalism?
I think what I want is I want a formalism that can meaningfully constrain judgments that agents are willing to make about things like independence and correlation and stuff like that, right? So I want that, because that's how you get confirmation theory going, right? So there's a whole, this is a very simple example, but this third condition is standing in for a whole lot of things I want. I want to be able to talk about correlations and independence. I want to be able to model updates, right? I want to do all that stuff. Okay. At the same time, I would like to be able to have something that can get really... I want to be able to model agents who have different types of commensurability and incommensurability going on, right? Who are willing to make certain judgments and certain comparisons, but not others. It would be nice if I could have one formalism to deal with that packs in all that information. When you're playing this game, like I said before, it's not like there's ever going to be a unique answer, because you could build a formalism, as we were just saying, that does all the things I just said and doesn't get as complicated as ranged credences. And then you're asking yourself questions about, okay, is this a simple formalism to use? How can I attach it to the other widgets I want, like a decision theory, et cetera, et cetera, et cetera, et cetera. But I'm not going to pretend that there's only one solution to this problem, right? There are a lot of formal solutions to this problem. And I think, maybe some of you don't think that this is a kind of judgment we should be trying to model, or maybe some of you don't care about the commensurability phenomena. That's fine. I think it's interesting that agents who have these sorts of gaps in the comparisons they're willing to make are nevertheless willing to make updates and make judgments about correlations and confirmation and stuff like that. And so I would like to be in the market for some kind of formalism that captures all that stuff. And there are a lot of them. The most obvious one that pops up is the one that people have been using for all sorts of reasons, which is the ranged credence one, right? But I'm not going to try to argue that that's the only one that would do the job. Yeah?
Are you aiming to capture comparative judgments about correlations? This correlation is...
Yeah, sure. Ultimately, yeah. Right? Where they're available, because sometimes those things go missing as well, right? Sometimes someone can tell you, hey, yeah, if I learned tomorrow was going to be cloudy, that would increase my confidence in rain. And then you start trying to drill in on how much it would increase their confidence in rain, and they can't really tell you, right? So I want that kind of, right? What you want to be able to get is as it were, precision where precision exists in the agent, and, though this isn't quite the right word, imprecision where the imprecision doesn't exist. And so what you want, what I want at least, is I want a very flexible formal representation. And of course, you're always trading off the flexibility of the representation versus the simplicity of its various components and things like that, right? And so for some purposes where you don't have to deal with this kind of situation, the comparative confidence ordering is great, or the traditional Bayesian representation is great. But sometimes the phenomena gets more complicated, and then I want a more flexible representation. Okay, so just personal report, that's what makes the whole range credence thing interesting to me. It's not perfect, as we'll see in a while, but that's what kind of makes it interesting to me. As I said, that's not the thing you find in the philosophical literature, right, that is going to motivate it. So in a minute, I'll get to the thing in the philosophical literature that motivates it. But first, I just wanted to work through an example. I know many of you have seen this kind of thing before, but just so we all have an example in front of us. How does this range credence formalism go? What you do is, instead of having one distribution of real numbers over propositions, you get a set of them. Van Frossen famously referred to this set as a representor. So that's what I'll call it. And then the rational constraint, or at least the first rational constraint you put on there, is that each of the distributions considered singly has to satisfy the probability axioms. So here's a really toy, simplistic representor. It contains only two probability distributions. For reasons I'm happy to discuss, your representor usually contains a whole lot more than that. But just to play with, this one only has two. Since these distributions satisfy the probability axioms, all we have to do to fully specify a distribution is tell you the values it assigns to each of the possible worlds. So if we've got two atomic propositions, we've got four possible worlds to worry about. Here are our distributions, right? On this one, the probability of A is 1/2 plus 1/4, which is 3/4. And since this one satisfies the probability axioms, probability of not A is 1/4. This one gives A 3/5, so it gives not A 2/5. Again, I assume most of you know this, but the way you tend to think about these, the analogy that gets used, is you imagine that the person who has this representor has a kind of committee in their head, and each of these distributions is one committee member. And the properties that are borne by the full agent are the things that all the committee members unanimously endorse. So you'll notice, the way I've set this up, both committee members assign a value of 2/3 to R. So we say that this agent, represented by this representor, has a degree of belief in R of 2/3. This agent's attitude towards A is a little bit more interesting. You get a range of values from 3/5 to 3/4. So we say that this agent's attitude towards A is represented by this range, right? We sometimes refer to the bottom of the range as the lower probability and the top of the range as the upper probability. Whereas this agent's attitude towards R is just the singleton 2/3. So that's how we model an agent whose degree of belief is exactly 2/3. All right, that's how we set this thing up. All right, and I should point out, for those of you who don't know the history, initially the way people ran this kind of model, so people like Smith and Keiberg and Good, is they thought all you needed to do was assign ranges to propositions and you were done. Then Levi in 1974, followed by some other people, made an argument that in fact going to a full-blown representor, a full-blown set of distributions, had all sorts of representational advantages over just assigning ranges to particular propositions. And I can get into that if you're interested, but that's why we tend to work with representors these days and not just ranges. Okay, so notice I built this representor so that it will represent the agent I was just talking about a minute ago, right? So if you look at this representor, this person has A more confident than not A, right, on both distributions. This person has R more confident than not R on both distributions. Both distributions assign 2/3 to R and 2/3 to R given A. So since it's a unanimous judgment, we say that this agent has R independent of A. But at the same time, on this distribution, right, A is greater than R. On this distribution, R is greater than A. So there is no unanimity on the comparison between A and R. So this agent just has nothing to say about whether they're more confident in A or R, because the distributions in their representor have varying opinions on that matter. Okay, so this is a representor that neatly captures the 4 features I was just talking about. Okay? And again, there are other options for how to capture an agent like that. We talked about some of them. Also, in the present context, dempster-shafer functions are another way to do it, right? There are a lot of ways to do this, but this is one of them. Interestingly, as I said, though, this isn't what people talk about in philosophy when they talk about why we would want ranged credences. What people talk about is they say that ranged credences represent a particular type of attitude, which is the type of attitude rationally demanded by certain types of evidence. So the claim, and especially the claim against traditional Bayesianism, is that sometimes you're faced with a body of evidence where no single real valued degree of belief is the rational correct response to that evidence. The rational correct response to that evidence is a different kind of attitude that is best represented by one of these ranges. That's the claim. Okay, what kind of evidence am I talking about? Well, here's an example, a fairly recent example that's gained some notoriety from Adam Elga. He says, a stranger approaches you on the street and starts pulling out objects from a bag. The first 3 objects he pulls out are a regular-sized tube of toothpaste, a live jellyfish, and a travel-sized tube of toothpaste. To what degree should you believe that the next object he pulls out will be another tube of toothpaste? Elga says the answer is not clear. The contents of the bag are clearly bizarre. You have no theory of what insane people on the street are likely to carry in their bags, nor have you encountered any particularly relevant statistics about this. The situation doesn't have any obvious symmetries, so principles of indifference seem to be of no help. It's very natural, Elga thinks, in such cases to say you shouldn't have any very precise degree of confidence in the claim that the next object will be toothpaste. It's very natural to say your degree of belief should be indeterminate or vague or interval valued. So this is the kind of evidential situation that Elga thinks calls for one of these ranged credences. And the question I want to talk about for a little bit is, what exactly is it about this bag of evidence, this package of evidence, that makes a ranged credence the correct response? I mean, the way Elga puts it, he makes it sound like it's something about precision, but a real valued credence is no more or less precise than a range of credences, right? They're equally precise representations. So it can't be that what's going on is this body of evidence calls for something less precise in the formalism. He also uses this talk about how your degree of belief should be indeterminate or vague or interval valued. I don't really like that way of talking. A few decades ago, it was very common to talk about numerically indeterminate credences. And what that meant was there was no single determinate number affiliated with your credence. So numerically indeterminate credence I can understand, but then that got abbreviated to indeterminate credence, which made it sound like the attitude is somehow indeterminate. And then people started calling them vague credences or mushy credences. I don't understand why. It's not clear that the attitude in question is in any way indefinite or anything like that. So that's why I like calling them ranged credences, because ranged credences is just talking about the formalism you want to use to represent this kind of attitude. Okay? All right. So what can we say here about the relevant feature of the body of evidence? Jim Joyce wrote an article in 2005 that I think is really helpful on this front. So he distinguishes 3 different features of evidence. what he calls balance, weight, and specificity. The balance of a body of evidence, and this is always relative to a particular proposition, it indicates which way that evidence leans on that proposition and how far it leans. So is the evidence in favor? Is it strongly in favor? Is it neutral? Etc. The weight of a body of evidence, relative to a proposition, captures how much information about that proposition the evidence provides. First thing to point out is these are two distinct features of evidence, and they can vary independently. Right? So suppose you've got your standard urn containing only black and white balls, and you're going to make draws out of the urn with replacement, and some draws have already been made, and you want to have an attitude towards the hypothesis that the next draw will be black. Well, suppose, first of all, the draws that have already been made, you made 10 of them, and they were 50-50 black and white, versus you made 10 of them, and they were 80-20 black and white, or 8-2 black and white. Those two bodies of evidence have different balances, right? This one's neutral, this one leans towards black. Now, on the other hand, suppose you made a 5-5 draw versus the case where you made a 500-500 draw. Those two bodies of evidence seem to have the same balance. They're both neutral about the next draw, but they have very different weights. Right? So notice the question of balance and the question of weight can come apart. They're two different features of evidence. All right. Balance and weight, at least arguably, can both be captured within the traditional point-valued Bayesian framework. So balance is really easy. You just look at the value of your credence in the hypothesis. Weight is a little bit more complicated, but the standard way to capture it is through what Skyrms called resilience. And the idea there is you basically ask, if I give you a particular body of evidence in the future, how much is your attitude likely to change? Or how much is your attitude going to change? To what degree will it change? And the idea there is supposed to be, okay, suppose I offered to tell you about 10 draws I made before you came into the room. I already made these 10 draws. I'm going to tell you about them in a minute. And you start wondering, when Mike tells me about those extra 10 draws, how much is my credence in the hypothesis going to change? The hypothesis that the next draw will be black. Well, if all you've seen so far are 10 draws, 5 black, 5 white, then hearing about my 10 draws might seriously change your opinion about the hypothesis. On the other hand, if you've already seen 1,000 draws, then hearing about my 10 draws is not going to change things as much. So your current attitude towards the hypothesis is more resilient when your evidence is weightier. And so the proposal here is you measure the weight of evidence by looking at resilience. The more weighty the evidence you've got, the more resilient your credence is going to be. And there are various ways to measure that, but they all involve doing something like comparing these two values. Point being, weight and balance can both be reflected in a point-value credence distribution. Yeah?
That's sort of interesting that I remember Popper arguing against a Bayesian characterization of belief by arguing that it couldn't capture the idea of weight.
Yeah,
But,
right.
Right?
Yeah, though there are still a few holdouts. And as best I can tell, like Mark Kaplan, and as best I can tell, what the holdouts want to say is the weight of your evidence should somehow be captured in the attitude you hold towards H directly, not in other attitudes around it or your dispositions for change, right? They want to say your attitude towards H itself has to be different in the different weight situations. I'm comfortable being more holistic about that and saying, look, as long as the weight gets reflected somewhere in your total doxastic state, I'm not sure why we have to single out its contribution to particular values. But to the extent I'm aware of people who still reject this, it's because of that issue. But yeah, it's not for the Popper reason, right? Okay, so what's the thing that's supposed to call out for the range credences? The thing that's supposed to call out for the range credences is this third category, the specificity of the evidence. And I will just tell you up front, there are a whole bunch of canonical examples of what specificity is supposed to mean. But when you actually press someone to say what specificity means, they tend to say things like this. So this is a quote from Joyce. In the terminology to be used here, data is less than fully specific with respect to X when it's either incomplete, in the sense that it fails to discriminate X from incompatible alternatives, or when it's ambiguous, in the sense of being subject to different readings that alter its evidential significance for X. Both incompleteness and ambiguity are defined relative to a given hypothesis, and both are matters of degree. This doesn't really help me all that much, right? I mean, the word ambiguous, in my mind at least, is kind of a synonym for something like unspecific. I get what the examples are supposed to be, right? The examples are supposed to be, I tell you that there's this urn, every ball in the urn is either black or white, I don't tell you anything else about it. That's supposed to be your canonical example of unspecific evidence, and then I ask you to take an attitude towards the proposition that the first ball drawn will be black. And when you have chance situations with incomplete evidence, those are the situations where people really bring up this unspecific stuff, right? Of course, there are other ways to model unspecific evidence. Again, dempster-shafer functions have a completely different way, right? This is supposed to sort of put us in the mindset of what we're talking about. It connects to the very famous distinction between risk and uncertainty that comes from Knight and then got popularized by Keynes. So the example you always get there is when you sit down to a roulette wheel, you are facing risk. You know what the probabilities are, you just don't know how the thing's going to come out. On the other hand, if you're faced with an urn and you don't know anything about its composition, then you're dealing with uncertainty, right? And the point that Keynes wanted to make is you shouldn't confuse risk with uncertainty, and famously he thought that's what the principle of indifference did. He said if you're faced with a situation like this, and you announce very confidently, my credence that the next ball will be black is 1/2, he said what you're doing is you're treating it as if it's a risky situation when in fact it's an uncertain situation. So Joyce would say you shouldn't have a point value credence of 1/2, you should have one of these range credences, right? Now, whatever specificity means, it does seem to be independent of the issue of weight. So here's an example from Brian Weatherson. Weatherson says, imagine we're playing a rather simple form of poker where each player is dealt 5 cards and then bets on who has the best hand. I guess it's you don't get to draw any more cards. This is really boring poker. Before the bets start, I can work out the chance that some other player, say Monica, has a straight. So my credence in the proposition Monica has a straight will be precise. But as soon as the betting starts, my credence in this will vary and will probably become imprecise. Do those facial tics mean that she's happy with the cards or disappointed? Is she betting high because she has a strong hand or because she's bluffing? Before the betting starts, we have risk, but no uncertainty, because the relevant probabilities are all known. After the betting starts, uncertainty is rife. Okay? So, point here being, at the very beginning, when all you have is the probabilities associated with the game, you're facing risk, you don't have a lot of evidence, but the credences you assign should be point valued, arguably, if you're matching them to the chances. Then you get more evidence. You see facial expressions, you see betting behaviors, but that evidence admits of multiple interpretations. So now you've got some uncertainty. Now your evidence has imprecision. Okay? So your evidence has gone from very precise to less precise, even though its weight has increased. Yeah?
This also seems related to how you would update if you would get more information. So I see it's different from weight, but it doesn't seem that different from weight.
Right, but notice, if you're capturing weight with resilience, what resilience tends to tell you is how big is the change going to be, right, when you get a specified body of further evidence. This is more complicated because part of what's happened is further updates can go in multiple directions, right? What happens in the model when you have uncertainty is if you think of these committee members, what's happening is the committee members are disagreeing about how to interpret the evidence you just got, and perhaps they're disagreeing about how to interpret future bodies of evidence, right? So, if you will, the committee members are all looking at one and the same piece of evidence you just got, and some of them are like, oh, that's evidence you're going to win, and some of them are like, oh, that's evidence you're going to lose. And that's why the spread happens, right? So, yeah, look, these things are not unrelated, but it's a different effect, and I do think it's interesting that, and you really see this once you start getting formal measures of resilience and formal measures of weight. You can just ramp up the weight a whole bunch while decreasing the specificity. So they do move separately, though not in a way that's entirely unconnected. Yeah. And by the way, if this is starting you thinking about dilation, I'm going to get to that in 1 minute, right? Okay. So, things I see as problems for the range credence approach. There are lots of problems. Let me just focus in on a few. I still don't know exactly what specificity means. And I still don't know when I'm confronted with a body of evidence how to figure out what its specificity comes to, how specific or unspecific it is, especially when we're not in very artificial urn or poker situations. Other notorious problem is no one knows how to do the decision theory for this stuff. The basic problem being, if you're confronted with a choice between two options, A and B, and the members of your committee disagree on which of the two options has a higher expected utility, what should you do? This has been a problem since the beginning. I mean, Levi was talking about this in the 70s. Lately, for some reason, philosophers seem to have focused in on it. So there's been a huge outpouring of articles in the last few years. I don't know that they've necessarily made any progress on this. So this is kind of a standing problem. The thing that is supposed to be a huge problem that I just don't see as a problem is dilation. So that's the next thing I was going to talk about, is dilation problems for this approach. Yeah, here.
If I could just try to ask about your difficulty with specificity.
Yeah.
Maybe it's related to mine, but I don't know.
Right.
If I'm looking at this on the previous slide,
Yeah.
this description, and you're saying that when does a body of evidence count as unspecific? So I assume that is Weatherson suggesting this is unspecific evidence?
Weatherson is suggesting that once you have this stuff about like facial tics and betting behaviors, that's unspecific. That's his claim.
If these things are being called evidence at all, wouldn't you just say that's the evidence? And there's just evidence and there's not, things are either evidence or they're not evidence, right? I mean, it's going into this, if it's in this resilience calculation, you're conditioning on something. And I just imagine in this case you'd be conditioning on these facial tics,
right,
assuming you had probabilities assuming.
Right.
Yeah, so there's no, but I guess unlike the resilience condition, there is no formal definition of what it actually means to be specific or not.
Yeah, I guess the problem is this. Keep in mind we're in the normative part of the range credence theory now, right? So what's going on is these folks are making an argument. And the argument is supposed to go like this, okay? There are certain types of evidence. We're going to call them unspecific. When confronted with unspecific evidence, evidence of that type, a rational agent will react by forming a particular kind of attitude. That kind of attitude cannot be appropriately represented by the traditional Bayesian point-valued formalism. It needs a different kind of formalism. That is supposed to be the argument for bringing these ranged credences on board. Now, if you're going to make that argument, it would be nice if you could tell me something about what type of evidence you're talking about that calls out for this particular attitudinal response that can't be modeled in the traditional way. Can you characterize that kind of evidence for me? Can you tell me what some of its discriminating features are? And you have to do it in a non-question begging way, because it's really easy to say, oh, it's the kind of evidence that requires assigning a range rather than a precise value, right? But then you can't make the argument, which is really the argument these guys want to make, right? They want to make this argument that there's a kind of evidence that calls out for a particular kind of response, but then you can't define that type of evidence in terms of the response. Yeah.
Do they say what the response is?
The response is to have an attitude that is best modeled as a range of values.
We're talking about a relationship between given evidence and a given question asked.
Yes, right.
It's not just a property of evidence.
Yes, that's true. Right, when I did the definitions of balance and weight and specificity, they're always relative to whatever hypothesis you're considering. You're right, I was speaking loosely. But there's this relation between the evidence and the proposition that is supposed to be unspecific, right?
So somehow this is floating for me. You're saying that somebody should be able to this sort of idea of what evidence is, what you're calling evidence is some kind of experience that you've had. It's not, it's very ill-defined, and you're making a judgment that maybe it doesn't tell you anything about this particular question, or that it tells you very little. Why are you demanding something beyond that judgment? What is there to demand beyond that judgment?
Well, and keep in mind, this is not my argument, so I'm going to try to represent the argument that these guys are making. When you say this evidence that I just received, and philosophers tend to express evidence as being propositional, so that's the way they tend to talk. They say, when we got this evidence, this propositional evidence, right?
Okay, so
When you, right.
We get
Yeah.
off the train right there, and
Okay.
then there's nothing to discuss, I guess.
No, there's plenty to discuss, right? You can talk about it as an experience. So let's talk about it as an experience. I had this experience. And the way you put it is, this experience told me very little about the question I'm interested in, right?
Making that judgment.
Yeah, okay. Now, the first question someone like Joyce would ask is, when you said tell me very little, do you mean in the weight sense or the specificity sense? Because those seem to be two different things, right? Because a piece of evidence can be very clear in its import while telling you very little, right? If I've done 1,000 draws from the urn and I take one more draw, that tells me very little, but there's no problem at all about how it's supposed to affect my credences, right? So the first thing Joyce would ask is, when you say this experience I just had tells me very little, do you mean very little in the weight sense or very little in the specificity sense? This whole argument that they're making for range credences only kicks in if you've had an experience that tells you very little in the specificity sense, right? So that's the first question they'd want an answer to. And then once you say that to them, right, they are going to have an argument about what is the right way to respond to that evidence. And what they're going to try to argue is that, for instance, the principle of indifference partisans have got it all wrong, right? They're going to try to say that if you apply a principle of indifference, you're going to wind up forming an opinion that is the wrong opinion to have in light of your evidential experience. Instead, there's something else you should do. And then you say to them, okay, what is the other thing you should do? And they're going to say you should form this other kind of attitude that is not best represented by a precise degree of belief. It's best represented by this range thing. So the question is, once you've made that judgment that your evidential experience tells you very little, in the specificity sense, not the weighty sense, what is the rational response to making that judgment? Or if you like, in a certain sense, in terms of the cognitive architecture it's generated, what judgment have you just made? Right? What is that? What's happened? And again, how can we best represent it? That's the argument they're trying to make. If that seems fuzzy to you, I'm on board, right? I mean, that's the structure of the argument they're trying to make, right? And this is, I mean, like I said, I've been writing a chapter about all this stuff, and just, I stare at this, and I don't know exactly what they're talking about, right? It's part of the problem. Which is why I said the other thing before, the descriptive part. At least there, I can start to say, what do I think it's like to make a judgment of independence? How does that interact with the other things you're willing to do? Your behaviors, your other judgments you're willing to make. There, in the descriptive argument for range credences, I feel like I can at least get a handle on sort of what we're talking about. This thing, I'm not sure how to understand specificity. And when you press people on it, what they do is they just keep pointing back to the same examples. You've got an urn and you don't know how many balls of each kind are in it, right? You've got a weighted die and you don't know the weight. Those are the examples they keep going back to, right? Sorry, you had a question, I thought, yeah.
So why think of this as evidence that you're getting rather than just not evidence? So like one way I might have thought about evidence is a proposition that's in your algebra of propositions that you have credences distributed over. So if you're getting something that's not in the algebra, you're not getting evidence.
Yeah, so suppose in this case the evidence you get is that Monica just pushed $20 worth of chips into the middle of the pot. Okay? It seems to me there's no difficulty representing that as a proposition in your algebra, right? I mean, we often have experiences that are much harder to define as propositions. This is what got Jeffrey going and all sorts of other people. But in this case, if it's just Monica pushed in $20 of chips, that's a pretty clear proposition. It can be in your algebra. The issue is, how does that relate to the proposition Monica has a straight? And the idea from Weatherson is supposed to be, right, that somehow the relation between the two is unspecific, so that if you're rational, the various committee members in your head are going to interpret it in all sorts of different ways.
So do we not yet have a credence distribution over the algebra, or do we have that yet?
So what happens in this particular example is you have this algebra, right? And at least for the part that you think Monica has a straight, at the very beginning of the hand, you have a precise point valued credence in that. Because you just do a bunch of math. There's 52 cards, here's the number of 5-card arrangements you can get, here's the blah, blah, blah. And you assume, objective chances. And so at least the proposition that Monica is going to get a straight, you have a point valued credence to that. And then Monica, and what your attitude is towards the proposition that Monica's gonna push in $20 in chips, that's probably something that these guys think you should have a range over. Okay. And then Monica pushes in her chips, and now your credence that she's got a straight has gone from this point valued thing to the ranged thing.
Okay, so
right?
I was thinking of it like you just start with a total function over the algebra, total credence function, and then it assigns a probability.
Total point valued credence function?
Okay,
right.
Function, and then it assigns a probability to every single element of the algebra. But this is it's a partial function that is only assigning.
Or it's a total function that assigns ranges to some propositions, namely propositions about what Monica's going to bet, what kind of facial expressions she's going to make, et cetera, et cetera, et cetera. Yeah. Because if you had, just the way the math goes, right? If you had point valued credences for all those things, that would create the correlations and that would tell you what to do here, right? And that's the traditional subjective Bayesian approach. The traditional subjective Bayesian approach is you've just got a prior that gives you point values over all these things, and that'll tell you what to do. And when you get unspecific evidence, right, what you should do is you should just do whatever your prior tells you to do, and then you'll have a point value credence. Right? There's a background argument here that I think you're beginning to sense about objective versus subjective Bayesianism. And some of these range credence folks hold out hope for an objective version of the theory, where what you do is, instead of applying the principle of indifference, when you're uncertain about things, you just go to ranges. And they're going to say, given any body of evidence, there is a unique rational response to that evidence over your algebra. It's just sometimes that unique rational response isn't going to be a point value, it's going to be a range. Yeah. Yeah.
On that point, it seems that then there's actually an alternative proposal, namely, you can have point value total prior function on all the evidential propositions.
Right.
But then what goes wrong in this case is the way that you update your belief. Namely, you are updating by once you have point value, then you have to update by conditionalization, but someone can object to updating by conditionalization, and therefore you don't have to go for a ranged value, you can just choose another update.
Yes. And we'll get to that in just one sec when we get to the dilation stuff. Yeah. Laura, you have a question?
Just a quick thing, because I'm not always clear that how people are thinking about it, but I can think of myself or an agent as having a sort of a large set of total functions, right? So it's not as though I have a sort of complete algebra that assigns point values to all propositions. I just have a lot of those. Like all of the members of my representor have their own.
Right. You mean you've got one and the same algebra of propositions, then you've just got a bunch of different distributions in your representor?
Right.
Yeah.
Each member of my representor, each committee member essentially has a complete point valued one.
Yes. And that's the way the model usually goes.
Yeah.
Is that everyone in the representor is a fully worked out total point value distribution over your language, and they share one language. That's the way it typically goes. You can get more fancy, so you can allow some of them to be partial distributions, but usually the way it goes is you've just got this set of total distributions.
And are you thinking of the range credence folks as committed to that, or?
Yep. Yeah. Here.
This is kind of tangential, but I'm curious in this, for those advocating for this range credence, in this I guess kind of in this exact example here. If I'm sitting at the poker table and I have a range credence that she has the straight is between 0.2 and 0.3.
Right, sure.
And she makes the bet, and then the pot odds are laying me 3 to 1.
Yeah.
Okay.
So
what should I do?
Yes. That's this problem, right? That's exactly this problem. So the answer that you get going all the way back to the start of this is, if your range is between 0.2 and 0.3, let's just say that her hand is better than yours.
Right.
If you're getting odds better, right? If you're getting odds below 0.2, it's clear what to do. If you're getting odds above 0.3 in the other direction, it's clear what to do. What do you do when you get offered a bet where the pot odds is between 0.2 and 0.3, and then everyone starts to argue? So what some people say is you should never accept any bets in that range. That's not a great answer for a whole bunch of reasons. One of the reasons is sometimes you're forced to make a decision and all your options, right? You can't beg off from taking one of the options. There are other problems with that answer. Another answer you get is what, and this is sort of what Joyce says. Joyce says, look at your whole representor. It's this whole set of distributions. Pick one of them and let that committee member drive all your betting behavior. First question, how do you pick that one, right? Second question, if when it comes to decision making, you're going to let one committee member drive the bus, how is this importantly different from the model where that committee member is just the only one you've got? And then Joyce comes back and says, look, let's not be too operationalist about this. There are things that matter about your doxastic state besides the decisions you're willing to make. There's a whole back and forth that happens. Then there are much more fancy people who have much more complicated things to do. But for exactly the reason you just said, there's no obvious way to do this. And I mean, you know, Levi in 1974 laid out like 6 different options. Since then, people have laid out more options, but there's no consensus on what to do, right? It's a big problem. Yeah, absolutely, right? Here's a just fun sidelight. I have a friend who, besides being a philosopher, has a side business doing consulting for various government agencies that need to do decision pooling. So they have experts on their staff and they want to form a group opinion from these experts. And he's been playing with different algorithms to help make these group opinions. The groups then make predictions and you check the accuracy of the predictions. And one of the first things he played with is, do you ask the experts for a single point value or do you ask them for a range? Which one leads to better predictions on various algorithms? And actually what he's found is most useful is you ask them for a range and a point value. Because that's extra information that turns out to help improve, under certain algorithms, the best prediction you can get. And so what he actually thinks is going on under the hood is that these people have some kind of distribution, right? And the range is telling you something about where the tails live, and you know, the point value is telling you something about how symmetrical it is. So there's more, right? There's further stuff we could do here. We could keep going, and then you could debate how to plunk that all into decision theory, right? Yeah. Yeah. All right, let me talk about dilation a little bit, and I'll stop just because this is one of the biggest complaints you hear about this whole theory, and there's 2 versions of it, and I don't think either of them is very good. There we go. Okay, so what is dilation? Roughly speaking, dilation is this phenomenon where you start with something narrow, a narrow range on a proposition, and then you learn something and it gets wider. Okay, so just if you're interested, the representor I showed you before, suppose you have this representor and then you learn if A then R. Somehow God comes and tells you if there's alien life then it's going to rain tomorrow. The traditional way to update a representor is to work with one committee member at a time, have each committee member conditionalize on the information you learned. So you conditionalize this one on that, and what happens is you basically take all the possible worlds inconsistent with that, set them to 0, and then just normalize what's left over. You get this. You conditionalize this one on the same information, you get this. And what's interesting about this example is before they were unanimous of a value of 2/3 on R, and now they've split. So you've dilated. You've gone from a precise point value on R to a range. Okay? This is supposed to be a huge problem. It's supposed to be exacerbated by the fact that sometimes you can anticipate that you're going to dilate. So sometimes you can know in advance, I'm about to run an experiment. No matter what result pops out of that experiment, my range is going to get wider on this proposition. So no matter how the experiment comes out, I'm going to dilate. That's supposed to be an even worse version of this problem. And here are some quotes of people talking about how dilation is a really big problem for range credences. So some authors do not seem to be particularly bothered by this. Others consider it disastrous for systems that attempt to model epistemic states by means of so-called imprecise probabilities. Moretti says, dilation remains an unsolved problem of the imprecise probabilities framework, which puts its applicability at risk. So the fact that if you start with range credences and you update them in the traditional way, sometimes learning is going to dilate you, that's supposed to be a problem. Now, as you just pointed out, it could be a problem for the credence ranges, or it could be a problem for the updating algorithm, right? But it's a problem for something in there, is the claim. Okay? It's worth asking why dilation is supposed to be such a problem. So Seidenfeld and Wasserman, reporting the opinion of their opposition, they don't endorse this, they report a seeming intuition that when we condition on new evidence, upper and lower probabilities should shrink towards each other. And I think what's going on there is that people think of dilation as some kind of epistemic degradation. That being in a position where you have a wide range is worse than being in a position where you have a narrow range. So as things get better for you epistemically, your ranges should narrow. Separate intuition, getting evidence is good for you epistemically. So when you get evidence, your epistemic position should get better. It shouldn't degrade. Well, if a widening range is things getting worse, and evidence should make things better, then it feels like intuitively getting evidence should never widen your ranges. I think that's what's driving these folks who are worried about dilation in this way, and I think it's just confused.
Yeah, it sounds like they just didn't take seriously the fitting formula.
Yeah, right? What they've done is they've just conflated weight and specificity. And you just go back to Weatherston's example, right? In Weatherston's example, you gain evidence. Monica pushes $20 into the pot, but this evidence is unspecific. So while the weight has gone up, and along that dimension your epistemic position has improved, the specificity has gone down because the evidence you gained is unspecific. And that's what causes the dilation. All right? I don't think that's very hard. People keep pressing this objection, but I don't think it makes a ton of sense. There is a more refined version of the dilation objection that I think is more interesting. We'll get to that in one sec. But this basic idea that, you know, dilation is going downhill epistemically and getting good evidence shouldn't drive you downhill, I think it's just confused. All right, so here's the more fun version, and this is more recent, and it came from an example from Roger White that was then modified by David Christensen, that was then modified a little bit more by Scott Sturgeon. The differences between the versions won't really concern us here. Here's the basic Roger White version. Okay, there's a proposition P. You don't know anything about P. You have no evidence about P. You're clueless. I, on the other hand, know what's going on with P. I'm certain about its truth value, and you know that I know what's going on with P. So we agree to play a very strange game. All right? I'm going to get a fair coin, and I am going to write the truth about P on the head side of the coin. Moreover, I'm going to paint over the coin so you can't see which side is heads and which side is tails. So heads is going to get the truth about P. I'm either going to write P if P is true or not P if P is false. And then, keep in mind it's a fair coin, I toss the coin in front of you, it lands, and the P side is up. And you're like, gee, that's wholly uninteresting, right? Because, I mean, okay, where did you start here? What are your priors like? Well, it's a fair coin, you're certain it's a fair coin. Let's say your credence that the coin will come up heads is 1/2. Got this mysterious proposition P, I don't know, there will be nuclear war in the next year or something like that. And you don't have any evidence about that, let's say. You probably have a lot of evidence, some of it comes from Twitter, but whatever. If you don't have any evidence about that, suppose you're assigning a maximal open interval from 0 to 1 to this proposition P. And White actually assumes, he doesn't say it here, he assumes that you're treating P and H as independent. So in the range credence model, that means each of the distributions in your representor considered singly takes these two propositions to be probabilistically independent of each other. Okay? Then we play this very strange game. I put the truth about P on the head side, I flip the coin, it lands P. What do you learn when the coin lands? What you learn is P is true if and only if the coin came up heads. Let me run through that for you for a sec, okay? If P is true, then P is on the head side. P landed up. So if P is on the head side, then heads landed up. So if P is true, then heads landed up. If P is false, right, then P is on the tails side. Well, P landed up, so that would mean that tails landed up. So that would mean that H is false. So if P is false, then H is false. If P is true, then H is true. So what you learn when the coin lands is you learn this biconditional. And now the question is, what should that do to your attitudes towards P and H? And if you just run the standard updating procedure for range credences, the result you get is that both P and H wind up with this range, the 0-1 range, in your posterior. And White and Sturgeon and Christensen and a number of others all think that's complete garbage. Okay, why is it garbage? Well, there seem to be two intuitions floating around here that they're invoking. The first one is, You had really, really good evidence about the coin that you were basing your prior on. You were at 1/2 on heads because you know things about this coin. Maybe you designed it physically. Maybe you flipped it a million times and it came up heads almost exactly, right? You've got really, really good chance evidence about the coin, and that's what your prior was based on. You don't know anything about P. You are a complete non-expert about nuclear war. So why, when you learn that they're correlated, should you act as if somehow you don't have this chance evidence about H? Why should you suddenly spread on H as if the coin itself were totally uncertain to you and you have no clue what's going on, right? So that's the worry. These folks all think that your attitude towards H should remain constant throughout. You should remain at 1/2 on H the whole time. Here's a second, more abstract intuition that floats around. The more abstract intuition is if you have two propositions, A and B, and you think they're independent, learning the biconditional between them shouldn't change your attitude towards either one. That's another intuition that floats around. Interestingly, that same intuition pops up under a very, very different guise in a paper that Hawthorne, Landis, Wallman, and Williamson wrote. And they use it to argue that the principle implies the principle of indifference. Same intuition, used for different ends, okay? Both these intuitions are wrong, so I'm about to tell you why they're wrong, okay? And here's where we get back to Speedy the racehorse. So Speedy, this is an example. It's at the top of your handout. It's from a couple of papers that my former grad student Casey Hart and I have written. So the idea here is you have a roommate, and he's a gambler. He even gambles on gambling. So when he goes to the track, he flips a fair coin. If it comes up heads, he places a bet on his favorite horse, Speedy. Comes up tails, he places no bet. You're absolutely certain the coin is fair. You don't know anything about horse racing. You do know that there are 6 horses in today's race, so you just assign credence 1/6 that Speedy is going to win. Whether that's rational or not, that's what you do. And you treat the coin flip and the race outcome as independent. Okay? Your roommate comes home and is happy, and there are only 2 things that make your roommate happy. Either he placed a bet and he won, or he didn't place a bet and Speedy lost. Right? Because he always bets on Speedy, so if he doesn't bet and Speedy loses, he's like, great, I didn't lose any money today. Okay? And so the question is, once you have this information, what should happen to your attitude towards Speedy and your attitudes about the coin? Okay, so initially, your credence in heads is 1/2. Your credence about Speedy is 1/6. You treat them as independent. And when your roommate comes home, you learn their biconditional. All right, notice there are no range credences in here at all. These are all point values. So let's just apply conditionalization, which, by the way, is something that Sturgeon, White, and Christensen are all perfectly fine with in this environment where everything is point valued. Well, you conditionalize, and it turns out at the end that your credences in H and S are both 1/6. And it's really easy to see why. Here's how you start. You got 12 possible worlds. You give them all equal credence. And then when you learn the biconditional, you block out these ones. Of the 6 remaining worlds, only one of them has H true. In general, if you have 2 propositions, you're at 1/2 on one of them and you treat them as independent, then when you update on the biconditional, your credence in the one that you were at 1/2 on is just going to drop to whatever the other one was. It can go up, it can go down. It's just going to be assimilated into whatever the prior was of your other proposition. Okay? And that's odd. It's counterintuitive. Updating on biconditionals is weird. So it turns out that 1/2 is a kind of magic value here. A value of 1/2 will just collapse into whatever else is going on. Different values work in other ways. So if both values are above 1/2, then your posterior winds up being higher than both your priors. If they're both below 1/2, your posterior winds up being lower than both. If they straddle, then something in between. Weird stuff happens here. Okay? When you play around with it a little bit, you can get used to it. But the point being, all the weird stuff that happens when there are no range credences involved. Right? So go back to these 2 intuitions we had before. The first intuition is if you have one proposition where you have really good chance information and then one where you don't have any good evidence behind it, the one with the really good chance information should stay. And in the Speedy case, that's just not true. You have really good chance information about the coin, but if that puts you at 1/2, then 1/2 is just a value that when you update on a biconditional is going to collapse into whatever your other value was. No matter what kind of evidence you had backing up that other value or not. It's just the way the math goes. Second of all, in Speedy, you had two propositions, H and S, that you took to be independent. You update on the biconditional, and one of them changes and the other stays the same. That's just what happens. Okay? And now think about what happens in the coin game. In the coin game, you've got your coin. You're at 1/2 in heads. And what that means is, in your representor, every single distribution is assigning 1/2 to H. You're at 0, 1 on P, and that means in your representor you've got all these distributions, each of which assigns a point value, each one assigns a different point value. When you then update on the biconditional, what happens in each distribution considered singly is, it was at 1/2 on H, so it does the Speedy thing, and its value for H collapses into whatever its prior was on P. So when you're done with that update, you've got all these distributions ranging in values from 0 to 1 on both H and P. Okay? That's just what happens. All right? It's counterintuitive, I'll admit. It seems weird, but all the weirdness has nothing to do with the ranges. All the weirdness can be seen in the Speedy case where no ranges are involved. It's the weirdness of updating on biconditionals that causes this apparent problem. It has nothing to do with range credence or range credence updating. Okay, so I take myself to have talked about 3 things. Whether I accomplished them, I talked about them. The first one is, I said maybe there's a reason you want this range credence formalism for purely descriptive purposes, if you want to be able to model a kind of agent who has these 4 features in their attitude set. Then I said, okay, there's this other argument having to do with range credences representing the correct or the rational response to unspecific evidence. Well, I kind of see what the folks are getting at there. I'm not entirely clear what unspecific evidence means. And then there's this apparent problem for the range credence that has to do with dilation. I think that problem is either confused, it conflates weight and specificity, or it's this more specific problem that actually has nothing to do with range credence and is all about biconditionals. All right, I'll stop there. Thanks. Yes, sir.
So I remember when I read the paper by Hawthorne and all, that I thought it was mistaken, but I don't remember exactly how their argument went, and whether I thought it was mistaken for the right reason. You were very persuasive about that being a bad reason. Could you recreate the argument?
Yeah. When you read their paper, it's very, very complicated. And there's all these moving parts, and there's all these crazy things going on. So actually, it took us a lot of work just to kind of peel out what the argument was. I think it helps to think about the argument White wants to make, and then you can kind of see in outline version what's going on with the other guys. So the argument White wants to make is this. White is arguing for the principle of indifference. And here's how one way he makes his argument. He says, think about the coin game. After you update on a biconditional, you have to assign the same attitude to both P and H. Right? And that's true whether you're in the standard Bayesian framework or in the range credence framework. Once you're certain of a biconditional, you have to treat those 2 propositions the same. And White says, okay, suppose you believe in ranged credences. What are your options? Because you started at 1/2 on H and you started at 0, 1 on P. Right? Here, let me write this down just so everyone can see what's happening. So you started, right? P is at 0, 1, right? And H is at 1/2. And because you updated on a biconditional, unless you're just going to drop the probability calculus, these 2 things have to come together somehow, right? And if you apply the traditional updating algorithm that the range credence people believe in, what happens is both of them go to 0, 1, right? That seems to White like a bad outcome. And you're like, well, what are the other possible outcomes? I guess they could both go to 1/2, but he's equally opposed to that because he doesn't think that by flipping this weirdly painted coin, you learned anything about nuclear war. So in fact, what he does is he says, aha, the problem here was with the setup. You should have been at 1/2 on here all along, right? Because he believes in the principle of indifference. So he's using this as an argument for principle of indifference as the correct response to unspecific evidence as opposed to this thing. And if you're at 1/2 on both, then everything works out very beautifully, right? Okay, now, yeah. Of what? Yeah, well, you know, modus tollens, modus ponens, right? Okay. If you look at what these other guys are doing with the principle of indifference, they're making structurally a very similar argument, right? What they're saying is, okay, the principle can force you on, so imagine you've got some A that you think you should be imprecise on, and then you've got some other B that's independent of A and that you know the objective chances on, right? They say, imagine now, I mean, they don't say this, it takes a lot of unpacking, but essentially what happens is they have a very fancy way to hand you a biconditional of these two things, and then they're like, once you get the biconditional, they have to match. And again, we're into this forced choice, right? And so they say, aha, the only way to get this to work is if you had applied the indifference principle of this thing to begin with. So they claim their argument is from the principal to the principle of indifference, because they're using the principal to set this value, and the result of their argument is that you wind up applying the principle of indifference to this one. But in the middle of their argument, they just make this assumption that if these two things are independent and you update on their biconditional, that can't disturb either of the values, which is exactly the same assumption that White was making. And if you make that assumption, plus a couple other little things, if you make that assumption, then yeah, you can make an argument about what the priors of these had to be all along, but that's a terrible assumption. And I've actually, so Casey and I wrote this thing, and it's essentially published. I can't remember if it's in print or not. And one of these guys, who was it? I want to say it was Wallman, wrote to us and said, basically said about the Speedy case, yeah, I don't think in that case you should update by conditionalizing. He is so attached to this idea that when you have really strong chance evidence for one proposition and no evidence about the other, learning the biconditional, this thing shouldn't change. He's so attached to that that he's even willing to give up updating by conditionalization in purely point valued cases. I am not so attached to that intuition as he is, but that's a way you can go, right? Yeah.
Remark about a reductionist.
Yeah. He wants to dig in his heels, and but that's just losing all the details. That's roughly what's going on. Yeah. Which was funny, because Casey and I, we wrote this paper about Speedy and talking about the problem with Roger White's argument, and then these guys published this thing, and we looked at it and we were like, this is just basically the same mistake in different clothing. Yeah. Wait, there was a whole queue. Okay, let's go there. Shall we just go around? That'll be easy. Yeah, go ahead, Glenn.
Oh, I just want to make the comment that your coin story, where you're painting a coin, if you repeated that with different propositions, somehow end up with a story where there would be non-trivial, profitable bets about the P's that you can make. I don't know what relevance that comment has to your story, but it's
right.
You are somehow conveying some power. If there was a repetitive situation, you would somehow be conveying some power to your partner by playing that game.
So what's happening is, okay, just to be clear, I'm the person who knows about P, and you're the person who doesn't know about P, and we play this coin flipping game, and you go to this on both P and H, right? So the way it's supposed to go is, right?
I'm not into going to either one of them.
Okay, yeah, right.
Do that.
Right.
I'm just sort of backing off from it and looking at a more general question as to whether I have gained anything from your conveying this information to me. And it seems to me that if it was happening repeatedly, I would be gaining some information about how many of the P's you've done this with to me are correct.
Right, yeah. So here's what's really fun about it is you're gaining information. The problem is, again, if we're going with this model, and heaven knows, right?
I have no problem with the idea that you might not gain any information about any specific one.
Right.
But I could be gaining information about how many of the 1,000 of them are correct, which would enable me to make some money from some people. Yeah.
So you mean if we played it and sometimes the P came up and sometimes the not P came up and vice versa? Right. Good.
Every time you painted the P on the heads.
Right.
And you kept doing it.
Right.
then I would have some information about these P's by
Yeah.
the time you're done.
Yeah, you would have some information about en masse what percentage of them were,
Yeah.
right, were true.
I could somehow-
Yeah,
I could somehow make some, I could do better betting than somebody who would 0-1 on all of them.
yeah,
Well, not
Yeah.
0-1 on all of them, but 0-1 on every statement, every joint statement about them.
yeah, right. So what's going to happen is, it feels like there's a set of bets you ought to be able to make that would make you a profit. And yet, if someone goes 0-1 on all the P's, they seem to have closed themselves off in some way to taking advantage of that.
Well, that's not logically true,
Right.
because you could be 0-1 on the individual ones, but not 0-1 on everything in their Cartesian product.
Right, right.
So that's just a comment. It's not
Yeah.
bearing on what you've done.
Yeah. Okay, so that's interesting. Because what's going to happen is, if you think of each of the individual committee members, they're all going to have opinions about the sort of distribution of all the heads and tails in the complete, suppose whatever, you do this 1,000 times for 1,000 different P propositions. Each individual in the representor is going to have some opinions about how the 1,000 coin flips came out. And those are going to be correlated in all sorts of interesting ways with things about what percentage of the P propositions turned out to be true. Right? Is that how it's going to wind up going?
I'm not sure that captures the comparative thinking. I'm not sure.
Yeah, I'm just trying to figure out sort of how that would sort of trickle through what all the individuals would be doing. Because what's going on to each of the individuals in the committee, right, is...
I'm not sure
Yeah.
that has any representation in your picture.
Yeah, I'm trying to figure out if it does or if it doesn't, right? I mean, it's tied to another thing, which is another complaint about this picture. Here's another complaint about this picture. Suppose you went with the version of the decision theory where you accept bets below your lower probability, whatever. You buy bets below your lower probability, you sell bets above your upper probability, and you refuse all bets in between. It's very easy to prove that someone who has that betting policy is going to miss out on courses of bets that they know are a sure thing, that they know will generate a profit in every possible world, right? So we already know about this picture that if you intersect it with the decision theory in a certain way, you're going to wind up with agents missing out on good bets that are in their favor, right? So what I'm trying to figure out is maybe what you're talking about leads to another version of that problem. And what I'd have to do is I'd have to think through how does it percolate through all this business into formalism. And I think that's a really, because what's happening for each individual in the committee is they start off at 1/2 on a given H, and then they have some opinion. Suppose they think P is really likely. When you learn the biconditional between the two, then that individual starts thinking H is a lot more likely because H has the same truth value as P, right? So I don't know if this more macro stuff about the distribution of H's and T's over 1,000 flips is going to get lost once you introduce those correlations via the biconditionals, or if there will be some way to recover it.
Right.
Yeah.
On your justification. So how would it differ? So I'm not quite sure. So just to make sure I understand.
Yeah.
So for example, if all my P's were true, so I was always writing P on the head side. So that would mean that after say 1,000 tosses,
Yeah.
I would see 500.
Yeah. Right.
What scenario would
Yeah.
change that? So if I'm considering a mix of true and false P's, would that change what I observe?
I'm just saying I would have some
Yeah, it's a good way to think about it.
bets I might be willing to make on some general statements about how many of the P's are correct.
Yeah, I'm not sure you would, right? So think of the case where, so out of all these people in your representor, so there's 1,000 P statements. There's one guy in there who thinks all those P statements are really, really likely, right? There's a guy in there who's 99% on all those P statements. And so when he sees the first coin flip come up P, he then becomes 99% confident that that coin came up heads. And then the next one comes up P2, and he becomes 99% confident. And so this guy winds up being incredibly confident that all the coin flips came up heads, right? Or almost all of them. And then there's another guy who becomes incredibly confident that almost all of them came up tails. And now, with both those guys, what bet are you going to make?
Well, if they always came up P, for example,
Right.
I would be willing to get pretty strong odds they aren't all true. If you did 500 times and every
Yeah.
time the P came up,
Uh-huh.
and I believed your story about what's
Right.
going on,
Yeah.
then I would give pretty strong, I would be willing to bet that not all the P's are true.
Right.
I think I'd do pretty well that way.
Uh-huh.
Whereas if it was a 50-50,
I'd be willing to bet they aren't all false also.
Yeah.
Uh,
Yeah.
That's just an example.
Right. Jim Joyce would say you're confusing uncertainty with risk.
I don't get that point.
Okay, so the extreme case is, imagine I picked 1,000 P propositions such that you were certain of all of them that they were true. Okay?
Excuse me.
Such that you were certain of them all that they were true.
wait,
Okay.
but how is that the scenario? Where
No,
is that?
it's not this, but
I
just
know this
run with
part,
this
but-
for 1 sec, okay?
Okay.
Imagine I happened to pick 1,000 P propositions to run this with, such that you were certain of all of them that they were true. Okay?
Oh, before you did this story,
Yes.
I knew they were all true.
Yes, just run with this example for a second. I'm going to use it to make a case about the actual, a point about the actual story. So imagine you started off with 1,000 P's that you were certain they were all true. And then I did this thing where I put the true one on one side and I flipped it and it came up P. And let's just suppose, crazily, it came up P all 1,000 times. Okay? What you would say at that point is, oh my God, we just got 1,000 heads flips on my coin. It's probably never going to happen again in my life, but we just got 1,000 head flips on my coin. Okay? So the extremal case where you're certain of all the P's that they're true, you're going to watch this happen and you're going to think that you just got 1,000 heads. Extremal case where you're certain of all the P's that they're false, right? You're going to watch this happen and you're going to become certain that you just witnessed 1,000 tails coin flips. It's going to be like Rosencrantz and Guildenstern, right? Okay, now, what the range credence people want to say is, if you are uncertain about each of the P's, right, there's going to be some complicated business about how you take their probabilities to be related. So we have to specify, do you take P1 to be independent of P2? Do you take P2 to be independent of P3? What's your joint probability distribution over the P's? But if you allow that there's someone in there who is very, very, very highly confident that all 1,000 P's are true in advance, then when that person is done, when that committee member is done watching this coin come up P 1,000 times, that committee member is going to be highly confident that what just happened was a run of 1,000 heads. And you're going to have another committee member who's highly confident that what just happened was a run of 1,000 tails. And so these committee members are going to be like, well, one of them is going to advocate for one kind of bet, the other one's going to advocate for another kind of bet, and you, as a unified human being, aren't going to know what to do with the bets. Right? And so to act like you should be betting in a specific way is to act like you have information about the P propositions that you don't have. That's what these guys are going to say.
Well, they can say that. I wasn't living in their world.
No, but do you see what's motivating them?
Well, this model this committee model, but
Right.
I'm not there yet.
Yeah, but there's a deeper thing underneath the committee model that's motivating them. The deeper thing is they want to say, put yourself in a position where you were antecedently really confident that all the P's were true. Put yourself in a position where you were antecedently confident all the P's were false. Think about what you would do at the end of the experiment if you had started at each of those starting places. Now, in real life, you don't have any evidence that discriminates one of those options from the other. So you should be open to all those possibilities, and you shouldn't commit to a way of behaving that would be the correct way of behaving if you had very specific information about the P's, but you don't have that information. That's the underlying story, and they think what's going on is their formalism is capturing that story.
You said something, I'm afraid I'm distracting the other people from asking questions.
It's fine.
But we could return at some point to
Yeah.
Frank Knight. It sounded like to me that he was being vastly misinterpreted there.
By what I just said or by
By
Keynes?
what you said Joyce would say, Jim Joyce would say that we were confusing risk with uncertainty. You can return to
Yeah. Yeah, here.
I just want to ask about this specific, the complaint against this specific, I guess, dilation.
Yeah,
change.
right.
I mean, I guess the way I'm seeing this is the question not different before and after the coin flip? I mean, before the coin toss, I have the probability that it will land heads is a half. After the coin toss, my credence in what just happened is, beforehand it's a chance of something that will happen. Afterwards,
Yeah. You can finesse that so it's the same proposition. So for instance, suppose I flip the coin and put it under a cup, right? And I haven't shown it to you yet. And then I say, what's your credence that the coin flip I did at 5 p.m. on Monday, March 19th came up heads? And you don't know anything at this point. You know it's a fair coin and you don't know anything about P, and you say 1/2. And then I show you what's under the cup, and it's got the P side lying face up. And now I say, okay, now what's your credence that the coin flip I performed at 5 p.m. on Monday, March 19th came up heads? So there it's the same question, right?
yeah, okay, so it's
Yeah.
not about, the temporal aspect isn't really what
Right.
I want. It's about, really learning what's on the top, which is P or not P, right?
Mhm.
Changes the nature of the question. Does it not change the nature of the question? And the information that you are obscuring information. You paint it over the coin, and so
Right.
heads and tails is no longer really.
Right. Why is it changing the nature of the question and not just changing the information you have about the answer?
Well, anymore, heads and tails is kind of a non-existent entity. Once
It's there, it's just under the paint.
epistemically, to what extent is it still there? If it can never be determined.
Well, we could always scrape off the paint. Right? Suppose the way we're going to play this game is I'm going to flip the thing, put it under the cup, ask you your opinion, then I'm going to lift up the cup, ask you your opinion, then I'm going to drop some solvent on the paint and ask your opinion. Right? There's one proposition there, and you can have thoughts about whether it landed heads or tails. You just have more or less information at various times. Right?
So you didn't address the issue of so you didn't bring up the paint thinner.
Well, or do it in the Speedy case, right?
But no. But
Right.
if I'm now, in that case,
Mm-hmm.
would I still dilate? Would I still go to 0, 1?
Until I drop the paint thinner on it, and once I drop the paint thinner on it and you see George Washington or whatever, then you're going to collapse to 1 on heads. And you're going to collapse to 1 on P, for that matter. Right. It's just like in the Speedy case, right? In the Speedy case, there was an outcome of the race, and there was an outcome of your roommate's coin flip. You're sitting in your room, so you don't know how either of those things came out. Your roommate, so at first, you're at 1/2 on the coin and 1/6 on the race. Your roommate shows up, he's all happy. You learn the biconditional. So you go to 1/6 on H and 1/6 on Speedy. And then maybe you read the racing results later in the day in the newspaper, and that's going to send you pretty close to 1 on either Speedy or not Speedy, and either heads or tails. right? There's nothing mysterious, I think, going on with the facts. Just information about them is sort of occluded at various points. You're getting partial information at different times.
Yeah, and I think it's about to what extent should your credence reflect that part.
Yeah, that I totally agree with. I thought you were concerned that maybe what we were doing is changing what question you were answering. And I feel like what's going on is the question is remaining the same, it's just you're gaining information about it over time.
Why don't we?
Yeah.
Think about it?
Yeah. Laura.
Yeah, so I think this is a friendly suggestion, but it's also a complaint, maybe.
Okay.
So I've never understood why emphasize credence folks focus on the upper and lower bounds, rather than just sort of talking, like, why don't we talk about, set credences rather than ranged credences?
Right.
And I actually thought that your sort of first gloss on the silly complaint about dilation has a lot more pull if you think of them as ranges in this kind of very...
And not as sets.
And not as
yeah,
sets.
right.
Yeah. So if you're only ever focusing on, sort of the upper and lower bound, well, it just seems like, and you think of these sort of tacitly as being a smooth range,
Right.
then having a longer range feels like being somehow less
Yeah.
opinionated, losing out.
Right.
But if if you've always got 60 million of these things and they just change in how they're clustered or coinciding or not,
They spread out or they bunch together.
You could have a really, you could have an isolated, really low lower bound, but everybody's bunched up at the top. And this gets to your other point about kind of distribution.
So it's not a convex set then?
Right, it's not.
But even if it's a convex set, you can have this sort of effect going on, right?
So this is mostly just a complaint about why should we still even call these things range credences?
Yeah, right.
And also a bit of a friendly suggestion of like, here's a little, we can explain away a little bit of why this feels like it has an intuitive.
No, that's a good point. Yeah, I mean, as Levi pointed out, a long time ago, there's a lot of structure you're losing if all you're doing is reporting the ranges. So I think nowadays a good way to think about it is the ranges can be a cute little summary of one aspect of what's going on in the representor, but even if the representor is convex, there can be all sorts of other structure happening. And so there's this really interesting, when you start playing with 0-1 ranges, you can have these cases where you start at 0-1 on a proposition, you gain evidence that is positively correlated with the proposition, and yet your ending range is still 0-1. And people want to complain about that, and they want to say, oh no, this person hasn't taken the evidence into account. But if you look at the individual distributions in the representor, what happened is every one of them upon receiving the evidence bumped up a ways. It's just, when you have convex distribution, structure a particular way, everyone bumps up, and it turns out that the upper and lower probability is still the same. So yeah, you're totally right. So I need an even better name than ranged credence. God, now I have to think about that. Okay, I'll ponder that. But yeah, you're absolutely right. Yeah. Go ahead.
I was totally convinced by how your example handled the second intuition, but I wanted to hear more about the first one.
Okay.
So the first one, the question was, why should learning their correlated cancel your excellent chance evidence about age, about coming up?
Right.
So I guess I felt like that's a question that's very specific for a range of range credences. So so the kind of big picture confusion is I don't see how going to a non-range credence framework and then showing that something happened. So in the non-range credence framework, your credence changes, but the precision of your evidence doesn't change. It's still just one number that you're assigning.
Right. So the way these people tend to put this business is they tend to talk about admissible and inadmissible information because they're working within the way you should use chance evidence is through the principle. So even in the Speedy case, what's going on is you have very good chance information about the coin flip. There's this other proposition that you don't have any evidence about at all. And then you find out there's a biconditional between the two, right? And the complaint is supposed to be, wait a second, why is this biconditional information inadmissible? Why does it rationally permit you to diverge your credence from the known chances of the coin flip, right? And I think that's the same complaint whether your response to the proposition you don't have any evidence for is to assign a point-valued credence, or whether it's to assign a range. The nature of the complaint is still, we have really good evidence on one side, we have no evidence on the other side. Why is something that we have no evidence about being allowed to act as inadmissible information that pushes our credence about the coin flip away from the chances?
So wait, on this setup, it is inadmissible, the biconditional is inadmissible?
Yep, it is. It absolutely is. In both cases, yeah, it's inadmissible.
And the thought is, your excellent chance, I see. Okay.
Yeah, right?
So,
yeah.
so you've learned evidence, but it's not chance evidence.
Right. And at least at a first pass, it's not at all obvious. I mean, look, inadmissible evidence is supposed to be something like, you see the outcome of the coin flip, you get partial direct information about the outcome of the coin flip, you know, whatever, get a crystal ball from the future, right? It's supposed to be something like that. It's supposed to be inadmissible evidence, and at least at a first pass, this doesn't look like that, right? I think in the end it is like that, because the only way to get a chance outcome correlated with a proposition, right? Well, think about how that could happen. If the proposition is really unlikely, then, right? I mean, think about the likelihoods going in, right? If you've got a proposition like Speedy that's really unlikely, it's at 1/6 from your point of view, and the coin is at 1/2. Do you think you're going to get the biconditional? Or do you think you're going to get, for instance, the negation of the biconditional? You're expecting to get the negation of the biconditional. And so when you get the biconditional, that's information about what the world is like. Something unlikely has happened in the world, right? And I think that's really what's doing the work in the Speedy case. Again, I mean, you know, you look at that picture of what's going on, yeah. Yeah, if heads came up, then something really unlikely happened in the world. That's the right way to put it. Conditional on heads, something really unlikely happened that gave you the biconditional. So when you get the biconditional, you're like, oh, then heads probably didn't land. That's what's going on, yeah.
Is that what Hawthorne et al. Do, is they take the biconditional as being admissible?
Yes, they take the biconditional. I mean, yes, that's essentially what they do. They don't say that, but yeah, that's what they do. They have this principle, and it's a sort of parenthetical in the midst of another sentence that says, oh, and by the way, you should take this biconditional as being independent, is the way they put it. So learning the biconditional shouldn't affect your credence in the chance outcome. That's what they say. But yes, they're treating it as admissible, yeah. Yeah?
Sort of related to this question, but also Harry's question. I'm thinking that there's a sense in which the things you're evaluating probably are changed. And that's reflected in the notions of independence that you're using. So I'm having a hard time to grasping what exactly the notion of independence you're using for.
Right.
Like the caveat, you say, oh, it's an implicit assumption in Rutgers' article that the two things are independent. If we cash it out in terms of a classical probability treatment, then you should not change your probability after conditionalizing, and I think that's probably what's driving the intuition. Right. So it seems like learning the traditional negates the independence assumption that you were making at the beginning, and there's a conflict there. So
okay, good. So the thing to focus on is, let's first start with the precise valued case, because it's easier. In the precise valued case, you've got two propositions, okay? And in the precise valued case, what it means to say that they're independent probabilistically is just that your credence for H given S equals your prior for H, right? That is supposed to capture an intuition that you think H and S have nothing to do with each other in some sense, okay? So initially, before your roommate shows up at your apartment, you think H and S have nothing to do with each other, and moreover, if you were to learn just H, that wouldn't change your opinions about S, and if you were to learn just S, that wouldn't change your opinions about H. Now, the mistake that's getting made is, here's a third proposition, H if and only if S. And what these people are assuming is, if you take these two things to be independent, you should also take these two things to be independent. Okay? As a piece of mathematics, that's just a mistake, because I can write down a distribution. I mean, I showed you a picture of it, where this holds true, but your credence in H given H if and only if S does not equal your prior in H. Okay? So as a piece of mathematics, it's just bad to assume that this thing should necessarily give you that. they're not doing it as a pure piece of mathematics. They have this underlying intuition, and their underlying intuition is, hey, if you're going to treat these two propositions as having nothing to do with each other, then you should treat these two as having nothing to do with each other. So that's the underlying intuition that's feeding them, right? So it's not like there's a confusion or we're changing the subject. It turns out when you unpack it that they have a very substantive intuition about how your priors should be arranged. Your priors should be arranged so that if this thing is true, this thing is also true.
Wait, how would the first thing be true again? You have h, so that's...
This one?
Yeah, you have h given s equal to ph, even
Yep.
though you have h finally equal to s, or...
Even though you have what?
And the biconditional.
Okay, so at first, you don't know if this is true, you don't know if this is true, you don't know if this is true. You have kind of middling credences in all of them. But you think these two things are independent, right? Which we can talk a bunch of ways about what it is to make this judgment that these two things are independent intuitively. The way you capture your judgment that these two things are independent is you have a prior that satisfies this equation. Now, what these folks think is, if you judge that these two propositions are independent, you should also judge that those two are independent. So they think anyone whose prior satisfies this equation, their prior should also satisfy this equation, right? Now, mathematically, I can write down all sorts of distributions that satisfy this but don't satisfy that. So the real sort of rubber meeting the road here is this judgment they're making that in real life, when you have two propositions that are independent, you should also treat their biconditional as independent of each one. I think that's just a confusion about how probabilities work and how probabilistic judgment should go. And I can give you all sorts of, examples, drawing things out of urns, et cetera, that once you realize what you're doing in your transition from here to here. I mean, again, the likelihoods are really important here, right? So if this is at 1/2, and this is at something really, really, really low, and you take them to be independent, then when I say to you, conditional on h, if h turns out to be true, do you expect the biconditional to be true or false? You're going to say, if h is true, it's very, very, very unlikely that this biconditional will be true. Why? Because this thing's so damn unlikely, okay? And then you learn that the biconditional is true. That's really good evidence that h didn't turn out to be true. It's really good evidence that h is false. So I even think intuitively, once you kind of spell out what's going on here, that's just a bad, probabilities are hard. I make intuitive mistakes about probabilities all the time, but you've got different clusters of people making this very same mistake about how independence of these relates to independence of those. I think that's what's going on under the hood. Yes, Harry?
I'm not going to try to
Yeah.
reform my question because I maybe pose it a different
Yeah.
way, which is just the number 1 on this slide.
Yeah.
Why should learn? So I think I would agree with you, or at least based on what you said, is that I don't see this as a problem.
Yeah.
Okay. And the reason why I don't see it as a problem is somehow related to the question I
Okay.
but I can't really articulate it. But I guess why don't you see it as a problem?
Why don't I see it as a problem that learning that they're correlated causes you to diverge your credences away from the chances on h?
Yeah, I assume.
Yeah, because of that.
Right.
Because of exactly that. Right? And notice, I don't think the question has changed in any way. I just think when you get this information, all of a sudden these two things get correlated and they become correlated in a very specific way.
And the information has changed.
Yes, the information you possess has changed. Right, yeah. Yeah.
Maybe I should have said that instead. But
Okay.
the words are, but I mean, I don't
Yeah.
see anything unintuitive about it.
Yeah, good. I'm so glad. Yeah.
See what else,
Yeah.
Yeah. There was something you said earlier, but anyway, go on.
Right.
If there's other questions.
All right.
I forget what else.
I had one more thought about how to explain to Glenn the thing that I was trying to say earlier. Is it worth trying, or should we just go with more of the question? Okay, let me try one more approach. Can I try one more thing?
What are you trying to explain to me?
The thing before.
Why you confused risk and uncertainty?
Yeah. Why, according to these guys, what you were saying confused risk with uncertainty? Okay. Or I could stop.
Or you could explain it to me. What does Joyce think the distinction is between risk and uncertainty?
Okay, so.
I actually read Frank Knight's book, and I'm always having the impression like if you were talking about that, they had not read Frank Knight's book.
You know much more about the right way to interpret night than I do, right?
Well, I don't know. Maybe you read it too.
I have read the relevant chunks of the book, but I have not spent as much time, I'm guessing, thinking about them as you have. So let me just tell you the way I think Joyce thinks about all this, okay? I think the way Joyce thinks about this, especially in these cases with urns and stuff like that, is he thinks sometimes your evidence is going to rule out certain chance distributions as being impossible, okay? So for instance, I might have an urn with 100 balls, and I learn that at least 20 of them are black and at least 20 of them are white. At which point, he thinks my distribution over the proposition that the next ball drawn will be black should be from point 2 to point 8, right? So he basically has this mindset where sometimes your evidence rules out certain chance distributions, but when you have that evidence, all the distributions that haven't been ruled out should be represented in your representor. So there should be at least one distribution in your representor for every chance distribution that hasn't been definitively ruled out by your evidence, okay? And then what he wants to say is, you are only allowed to take something as true of you as a whole if it's agreed to by all those remaining distributions, okay? So now, let's imagine the case you're talking about where we run this coin game 1,000 times, okay? And let's write down the 1,000 P propositions, right?
No, I get your point.
Right. And the point is that there's going to be people in your, right?
It's not, I mean, this sort of committee view is not of a great interest to me.
Okay.
And I think it would have been very foreign to Frank Wright.
Okay, sure, right. But I think where it ties into the risk versus uncertainty thing is that I think the way Joyce thinks of that distinction is risk happens when you know for certain what the chances are. Uncertainty happens when you don't know what the chances are.
Okay.
And when you're in the uncertain,
Got it.
right?
Got it.
Okay, good. And then,
I don't think that's what.
okay, that's fine.
About risk.
Yep, that's fine. I'm totally fine with that. Yeah, but I think if you're thinking about those concepts the way Joyce is, then in fact what's going to happen in the coin game is there's going to be no set of bets that you're going to be on board with, even once you do it 1,000 times.
You know, there's a more general question here that I'm curious about, which is, of course, I'm such an old guy. I corresponded with Peter Wally before he wrote his book about imprecise probabilities.
Well, you wrote your book before he did.
Yeah.
Much before.
You know, and I read his book, and then we had this Society of Imprecise Probabilities.
Yep. Still exists, I think.
It still exists. It still meets.
Has a website.
And Wally had this concept of what he meant by imprecise probabilities. But now, in philosophy, this idea of this committee view doesn't seem to me to be Wally's way of looking at it at all.
Right.
So I'm gradually, but you're not the first person I've heard talking.
Yeah.
Just in the last couple of years, coming to the seminar, I've started hearing philosophers talk about this.
Yep.
And my impression, I'm forming the impression that the philosophers have a understanding of set probabilities or range credences, or which is very different, which is this committee view.
Right.
So I guess I have a question under this is, am I correct to understand that this committee view is the received understanding of imprecise probabilities in philosophy, and it's not what Wally was talking about? Is that an accurate?
To complicate that a little bit, I also don't think it's what Levi was talking about. So reading Levi has the advantage.
But am I correct that this is, so this committee view is now kind of a consensus about a kind of certain view? That if you say imprecise probabilities to people in philosophy, this is what they think you're talking about? Is that accurate?
Not quite all of them, because some of them still have Levi's view, for instance. Like I think Teddy Seidenfeld still has Levi's view.
Well, he would about everything.
About a lot of things, right? Whether he would call himself in philosophy, that's another question.
What is the name of this committee view? Is it got the name imprecise probabilities in philosophy? It's got some other name.
Can I just ask really quickly what you mean by the committee view precisely?
You were describing.
Okay, but there's a few different parts of it, okay? One part of the committee view is you represent an agent with this set of distributions, and you say that the agent as a whole has a property only if it's unanimous among all the distributions.
Yeah.
So that's one part of the committee view. There's another part of the committee view, which is this story about how you're supposed to respond to different packages of evidence. Those two things are in principle separable, right? So which one is the one that you're worried about the most?
Well, I just want to know what words to use to describe
Right.
the way.
Well, do you think Wally believed in that first part? That you have this model and we say something is true of the model as a whole only if it's true of all the individuals in the model? Do you think that was part of Wally's view?
That's not really the basis of it, no. Do you?
Well, but do you think, I mean, look, even when I say it that way, it's not quite true, because one thing that is true of each of the individual distributions is it's point valued. So unanimously, all the distributions are point valued, but that doesn't mean we think of the agent as a whole as point valued. So even then, there's a little art in the interpretation.
Wally was starting with this betting concept. These are bets that I am inclined to take.
Right.
And maybe there's more bets that I would be inclined to take, but I haven't gotten around to thinking about it.
Okay, right, yes.
That's the way he...
But he would say, for instance, that if you've got one of these representations with the set of distributions, and relative to every distribution in the set, a particular bet looks like it maximizes expected utility, then he'd be in favor of taking that bet, right?
He would be inclined to take it.
Yeah. So that's a version of this view where if everyone in the committee agrees, then the person as a whole should go for it.
Yeah.
Right?
Yeah.
Yeah. I mean, it's also complicated because Wally was not necessarily doing the same project that these guys are doing, where they're very worried about attitudes of individual agents and whether those attitudes are rational, right? I mean, Wally was doing a lot of things, right? Which is why I said at the beginning that you really have to focus on which application, right, you're looking at. I mean, you've done a ton of things with formalisms that are nothing like this, right?
General term, is that the general term for this view in philosophy, or use range credence?
I think if you said imprecise probability to most philosophers, this is the view they would think you were talking about. Some of them call it mushy credence, some of them call it mushy credence, which I really hate, but that's a term that gets thrown around. Some of them call it vague credence, which I think is even worse because that conflates it with the theory of vagueness. There are a few people like Robbie Williams who thinks actually the time you should be using this is when you're faced with vagueness in the literal sort of philosophical sense of vagueness, like baldness and things like that. So there are some people who want to call it vague credence because they explicitly want to tie it into the metaphysics of vagueness, but most people who call it vague credence aren't thinking about that at all. So the terminology has sort of become a mess, which is one reason I kind of wanted to use my own terminology.
Philosophers probably wouldn't very often use this formulation that Wally used about bets I would be inclined to take. That would seem too...
Yeah, unless that's read in a really kind of strict dispositional way, right? Yeah. There's this weird hangover of operationalism and sort of behaviorism that floats around all this that we all officially gave up on decades ago, but when the rubber meets the road, everyone's really worried. Okay, what bets are you going to take if you have this attitude, right? And they act as if that's going to pin down what it actually is to have the attitude in question. So they'd say something stronger than the bets you're inclined to take. Yeah. Yeah.
Thank you.
Sure. Yeah. Laura, what was your question?
Well, I just wanted to ask about going back. So you started by giving us what you thought were sort of the real or
Turn on the lights. Yeah.
would be good motivations.
Can all
for
wake up a little.
credence view.
Yeah.
I was hoping you could talk about how we actually get all that stuff from a range credence view.
Okay. So you mean those four properties?
Yeah, I'm just a little bit worried that it's not, I don't know.
Okay, so they're listed here on the front of page 1 on the handout if you can't see them anymore up there. So I wrote down that representor, and at least to me it looks like the representor at the bottom of that page represents an agent who has all four of those properties.
Right.
Right?
So I guess I have a hard to articulate worry that you haven't really captured 4.
Okay.
Because I think that, in fact, this agent is quite opinionated about the comparison between the
Mm-hmm.
he's got sort of two different ways that he's considering that those things might be compared.
Yeah.
He's got exactly two of them, and they're very precise.
Mm-hmm.
And so
Right.
I just feel like in some
Yeah.
ways you inherit all the difficulties of assigning
Yeah.
cardinals.
Would it be better if I just constructed the convex hull of these two? Would that alleviate your concern? Because that's in practice the way people, I mean, there are debates about whether convexity is a good idea, but even people who don't think convexity is a good idea are going to have typically infinitely many distributions inside these representors. And so it's going to, I mean, I wrote this down. Another piece of violence I did to the mathematics is I wrote this down as if it gives rise to a range on A, but actually it doesn't give an interval, it just gives two values. So really, if you were actually doing this, you'd have infinitely many, and for every value between whatever 3/5 and 2/3, you'd have something, you'd have a distribution in the representor that has that, right? So then you'd have infinitely many opinions about how these two things relate, and you'd have somewhere in there, you'd have one distribution where they have the same value, right? So it's really, the person wouldn't even be decided that either A is better than R or R is better than A. There's going to be someone in this distribution in there that thinks they're equal, right?
Yeah.
So yeah, I was just trying to make it really easy to look at, but I think in the way you'd want to run the model is you'd want a lot more distributions in there. You're right, this person would still be pretty opinionated on what's going on, but then if you really, I mean, look, I gave you a very sketchy treatment of what's going on with this person and what they think. Yeah. If you give me more details and in fact their opinions are wider than that, then I just tweak my representor to give them more complicated stuff going on, right? Yeah.
I'm still a little bit skeptical, but
Okay.
But that sounds like it would help.
Yeah, right, right. Yeah, a 3-page handout is bad enough. If you make me list infinitely many distributions, yeah.
I actually would like to go to dinner, but
Okay.
I want to say something about this.
Okay.
Because I guess I'm having, and I don't know the terminology, but to me there seems to be a difference between this representer approach and the concept of arranged credence.
Yes.
Are they supposed to be the same? Or,
Okay, so here's what happens. Here's one formal model you can give. You can give a model where you just have a language of propositions, and to each proposition you assign an interval, right? Here's another model you can give the representor thing. Obviously the representor is also going to spew out intervals for each proposition. The representor model is a lot richer than the just I've assigned an interval to each proposition model.
Yeah, but I guess on this
Right.
point, I wonder, because you could have distributions in your representer where probability of A goes, well, let's change the,
Yeah.
goes down from 3/4 to 3/5.
Yep.
And probability of R goes down from 2/3 to 1/2, let's
Yep.
say. But it does it in a way that A is always,
Yep.
each of those distributions, A is always
Yes.
a higher probability, but
Yes.
the intervals overlap,
Yes,
right? So-
right. Yeah, so you're talking about, suppose, right, A goes from, I don't know, whatever, 0.2 to 0.6, and then R goes from, right, 0.4 to 0.8, right? And now the question is this person more confident in A than R? And one of the things Levi said when he responded to Good and Keiberg and those folks is, the problem is this representation of what's going on with the agent underdetermines how they compare A and R. Because you could have a version of this agent where this agent is absolutely certain that R's probability is 0.2 greater than A's. And that agent, right, would be more confident of R than A. And then you could have another agent consistent with this who, right, and that was one of the arguments for bringing in the full-blown representor thing. Because you've got this many-one relation between the representors and this, where some of them have R greater than A and some of them don't have any univocal opinion on that, right? And that was exactly one of the reasons why Levi wanted the full-blown model, because then, once I specify to you what the full-blown representor looks like, you're going to have an answer to the question, does this person compare A and R or not? Yeah. Yeah.
So I think my worry was, when you ask that yes or no question, do they compare A and R or not?
Mm-hmm.
There's always going to be something you can say. You can say, well, you know, about 3/4 of their representers think that R is more probable than A, and then the other, or there's always going to be something you can say.
Yeah.
And I just don't think you can capture the intuitive idea that they make no comparison.
Okay, but this is a game we get to play when we're building a formal representation of an agent. And the game we get to play is we build the formalism, so we get to say what the rules are for which aspects of the formalism count as being significant or not. And we can just stipulate, when I build representors, things about what fraction of the distributions in a representor have a particular feature, those are not significant in the model, right? And we can say, here you go. An agent is willing to make a confidence comparison between A and R if and only if there's unanimity among the distributions in the representor on that comparison, right? Since I built the model, I get to specify the bridge principles between the model and what's going on in the agent. So I have now stipulated that, right? And so now when you look at the representor, you have a firm answer to whether that representor is representing an agent who makes the comparison or not, given my bridge principle, right? We just say, look, all this stuff about sort of percentages and whatever, that's meaningless. It's a feature of the model that's not in the agent. And that happens all the time with formal modeling, right?
Yeah.
Yeah. Yeah. You got to be really careful, right, about what you're willing to read off a formal model into reality.
Right.
Right?
That sounds right. I don't really understand the desire for making unanimity the... So, I mean, maybe this is just too much clarification,
Yeah.
too much to go into, but I do just think that it's, especially because of the notation of just always focusing on the endpoints, it's very easy to ignore that there is this much richer body of data underlying, and why shouldn't it be normatively significant if all of your representatives are clustered around a specific point, is kind of, is one word that I've always had about this kind of general approach of actually having this very rich formalism available, but really only caring if the endpoints collapse.
Yeah. So there are people, so for instance, take Levi. When Levi talks about what all this means, the way Levi tells the story is, he thinks what's going on when you have a representor is, you think every distribution in the representor is a rationally permissible state that an agent could be in, and you're just suspending judgment. Like, put it this way. You think there's only one rational state for the agent to be in. You don't know which one it is. The candidates that are open to you are the ones in the representor, and you're suspending judgment among them. On that reading, it makes a lot of sense that if all these possibly permissible states agree on a feature, then you know that feature is required of you. So on that reading, the unanimity actually makes a lot of sense. That's not the reading I would want to give to this stuff. The way I like to think of this stuff is, look, it's a formalism. It only has the meaning we give to it. And so I don't think there needs to be any independent argument why to use this unanimity criterion. I think what you should be looking at is a package of the formalism plus the bridge principles you give it. And then you ask yourself, given that package of formalism plus bridge principles, what can I do? What kind of results does it give me? What kind of agents can I represent? Right? And so you don't need to intuitively motivate the individual pieces. Sometimes if you can attach intuitive meaning to them, that helps people think about what's going on. But in the end, the target of assessment should be the entire package. Formalism plus bridge principles. Sure. Right? And you should just ask, what can I do with this and what can't I do? And if it turns out that assigning bridge principles that give sort of meaning to more stuff inside the formalism gets you good results, then go for it. But I try to avoid thinking that way to the extent that I can. Yeah. Yeah, I don't want to keep anyone away from dinner. I'm here all night, as they say, right? But yeah, thank you guys. Yeah. Whew. Like I said, I'm here as long as you want me to be here. I can talk about